Well, good morning. Thank you all for attending this session today about how to manage user identities and access control policies using API Umbrella. My name is Francisco de la Vega, and I will be taking care of the first part of the session. I will be showing you what is API Umbrella, what basic things can be done with API Umbrella, and how you can secure your different APIs using API Umbrella and using a role-based access control mechanism. In the second part of the session, Dennis is going to take care of the advanced functionalities and is going to show you how to use a policy-based access control in order to secure your different APIs and the new features that has been implemented in API Umbrella in order to support this functionality. First of all, what is API Umbrella? In the context of FIWARE, API Umbrella is implementing two different generic enabler features. It is implementing, on the one hand, the PEP, as API Umbrella is a proxy that is intercepting all the requests that are made to the different APIs you are trying to protect, and is going to check the user permissions. If the user is authorized to make the request is going to be redirected to the API. And if the user is not authorized to perform the request is going to be rejected. On the other hand, API Umbrella is also implementing the PDP features, that the policy decision point features, as API Umbrella also provides the functionality to define the access policies that are going to be used in order to validate that the user is authorized to access to the service, and also is going to decide whether the user can access or not. So it's implementing the two things. The initial version of API Umbrella was initially developed by the US government, in particular the National Renewable Energy Laboratory, and then we adopted API Umbrella within FIWARE, and we enhanced API Umbrella features with new stuff that we consider interesting, mainly features and security protocols. API Umbrella is providing two main features in order to secure stuff. On the one hand, it supports securing API services, an API backend. This is the typical use for a PEP proxy. I mean, you are going to secure something like a context blocker, something like Quantum Leap, an API software. But it is also providing functionality for securing website services. Basically, it works as a reverse proxy. API Umbrella comes with an engines, and you can register the mapping between the front-end host and the back-end host, provide the certificates for SSL and these kind of things, and use API Umbrella as a as a reverse proxy. Well, the main features with API Umbrella are this one. API Umbrella is supporting a couple of different authentication mechanisms and security protocols. The most simple stuff is the local users with API keys, which is basically what was implemented by the NREL, by the US government, just API keys that are fixed in order to access to the different services. But then we in FIWARE integrate API Umbrella initially with Keyrock, which you know is the identity provider that we are providing in FIWARE. So API Umbrella is supporting OAuth 2 bearer tokens and also JSON web tokens with OpenID Connect. And we are supporting the different application roles that are defined in the different applications within Keyrock in order to establish what roles users might have in order to access to a particular resource. And well, and then we are also integrated with Keyrock and the I4Trust authorization registry policies that are going to be presented by Dennis at the end of in the second part of the session. Well, we have this integration with Keyrock, but we are also integrated with other identity manager, which is called Keycloak. Keycloak is provided by Red Hat, and well, we are integrated. So we're integrated with it. So API Umbrella is supporting JSON web tokens that issued by a Keycloak instance, and within Keycloak we are supporting two different mechanisms for access control. We are supporting roles defined at real level and roles defined for a particular client. Both of them are supported in order to specify the access control within API Umbrella. Okay, So the first and more important stuff that needs to be known regarding API umbrella is the concept of API backend. An API backend is basically the API that you are going to secure with API umbrella, all the API services that you are going to secure with API umbrella. When you are registering these API backends, the first things that you need to do is to configure the redirection. The redirection establishes how a specific front-end host with a specific path needs to be rewritten to the API host, the API path. This is something quite interesting because there are different possibilities with this redirection. It is possible to have a single host name for the whole API umbrella instance and then use different front-end paths in order to redirect the request to multiple APIs, or API umbrella is supporting multiple front-end host names. So you may have multiple host names with the THEA certificates, all of them managed by the API umbrella, and then you can map all these front-end hosts to the different APIs that you are securing. Once you have this redirection configured, you have a couple of settings that can be applied to the backend service. Basically, here is where you establish the authentication, whether the API is going to be public or it is needed an identity via an API key or via a web token, and then the authorization, which are the different required roles that a user must have in order to access to that specific API. API umbrella also have a couple of extra configuration parameters. For example, you can establish headers and parameters that are going to be injected automatically in the backend request. This is quite useful, for example, in those scenarios where you have an API that establish, for example, a basic authorization, a basic header authentication, which is just a header always with fixed stuff, or a backend API key, or these kind of things. If you want to enhance that security, you can place that on behalf of API umbrella, configure this parameter to be injected in the request, and use API umbrella security instead. And well, it also has other possibilities like configuring the rate limiting, etc. Apart from these settings that can be applied to the whole backend service, it is possible to define fine-grained policies using what it is called the sub-URL settings. The sub-URL settings is a way of picking just a subset of the API you are securing and applying a specific setting only to that specific subset. This is how the access control policies are implemented. So when you establish this subset, you need to provide which is going to be the HTTP method from the request, what is going to be the regular expression for the URL, and what is going to be headers that must be included in the URL. With these three things, you are able to match a request with a specific subsetting. One interesting point is this required headers functionality, which is establishing that you must provide a header with a specific value. This is very useful in the FIWARE context because if you are familiar with the FIWARE context blocker tenants, the specific tenant is placed in a header. So using the required header functionality, you can create access policies and settings that only apply to a specific tenant in the context blocker. Of course, these settings are able to override the ones from the global setting, so you can add low security levels for a specific subsetting. For example, you may define that a user must be administrator of the system for the whole backend service, and then allow just a specific get URL for retrieving some data that is going to be shared with a low access level, for example, a customer and these kind of things. Okay. Then the second object that is managed within API umbrella is what is called the website backend. The website backend functionality is the one that is used in order to set up a reverse proxy. You can just specify which is going to be the front-end host and protocol, and how this host and protocol must match with an internal server and port. And that's it. It's the typical configuration for a reverse proxy. All the digital certificate stuff is going to be managed by the API umbrella. So you can use this stuff in order to have secure SSL certificates and establish an HTTPS for your websites. And the final functionality that is provided with API Umbrella, which I think is something quite interesting, is the analytics thing. API Umbrella is actually logging all the requests that are made to the different APIs, and is providing you a couple of tools in order to see analytics of the different requests that are made to the system. Basically, it allows you to access to the API drill down, which all the requests are displayed per API backend or per service, and you can see the number of requests for a specific host name, and you can go deeper by path. So you can see how many requests has been made to each of the specific paths. You can also see the request by user. So you can see for a specific user how many requests he has made to the different APIs, or by location. Basically, you can see the origin of how many requests has been done from a specific origin of all the requests. These are the basic tools that come with API Umbrella, but as can be seen in the image, you can customize the queries to the backend. So you can customize the query adding things like the response code, whether the request has been rejected or accepted. This is the size, for example, you can establish the size of a request just establishing the headers and these kind of things. So you have a lot of possibilities in order to see how this stuff is actually working. Okay. So this is the introduction to API Umbrella. So what I'm going to do now is show you how an API backend can be configured, so we can see a little bit how API Umbrella is working. So what I'm going to do is accessing to API Umbrella. Okay, this is how API Umbrella looks like. You can see that we have this navigation here where we have the analytics section, the section for local users, and the section for configuration. So if you want to configure an API backend, you have to go to the configuration section and then move to the API backends section. At this stage, you can see that I don't have anything here. But what I'm going to do is to configure, this is running locally in my machine. So what I'm going to do is to configure some security for a context blocker that is currently running in my machine. So the first thing that you need to do is go here, add API backend. And now we have a couple of information to be configured. First of all, we have to provide a name for the API. In this case, it's a context blocker. So I will say that it's a context blocker. And now the next step is configuring the redirection. So we need to provide where the context blocker is actually running. Well, my context blocker is now running on HTTP because it's not with SSL in my machine, and I have to provide which is the server. My context blocker is running in Orion.docker in the port 1026. Okay, so this is my context blocker configuration. Now I need to provide the redirection. In this host section, you define how the host header in your request must be translated when accessing to the backend host. In this case, and I am in my local machine, I'm going to use as a frontend host the host name from API Umbrella, as a backend host the host name from the Orion context blocker. But in a typical production environment, what you are going to place here as frontend host is the host name, the real host name that you are going to use in order to access to the services. I don't know, for example, if you have a context blocker, it could be context dot whatever dot this kind of things. And as a backend host, you can also place the same name as here, because this is going to be writing in the host name, and in some scenarios you may need that the host header that is provided to the backend service is the actual one, the one that has been used by the users rather than the local one. This is up to you. And then we have the matching URL prefixes. Here is where we can create some redirections based on path instead of based on front end. Imagine this scenario, like the one that I have here, where I only have one single host name, which is the umbrella host name or any other host name, but I only have one. But I want to deploy a complete subset of APIs. Maybe I want to deploy a context blocker, a quantum leap, etc., all of them running in the same front end. domain name because I only have one. One thing that you can do is establishing that when accessing to this path, you are going to redirect to this specific path. This way you can register multiple API backends, all of them with the same front-end host and different front-end prefix. So with a path, you are able to redirect the request to the different services on the backend. In my case, as I only have one single service, I'm not going to do this kind of thing with the path, and I will leave the whole path as it is by default. So I'm going to translate root to root. Okay. Now we can move to the global request settings. Here is where you can add some query string parameters, where you can add headers, where you can provide a basic HTTP authentication in case your service uses it, etc. Here is where you can establish the external authorization, which is something I'm going to do later. Well, you can see that we have a lot of things here, whether to verify the identity, which are the roles to access to the service, etc. In my case, we are going to establish that only admins are able to access to this context blocker. You can see that the only thing that you need to do is to write the name of the role, and now the role is here. Okay, and I'm going to create a sub-URL request in order to have something a little bit more open. So what I have done is stating that my context blocker needs admin in order to access to the context blocker. And what I'm going to say is, in the specific case, when the request is a GET request, send to this URL, which is the query URL for the context blocker. In this specific, sorry, I'm going to copy. In this specific FIWARE tenant, then the user can make the request if he has a role called customer. And finally, I need to place that we need to overwrite the required result from the global request settings. This stuff is mandatory because if you don't check this checkbox, API Umbrella works like an ant. So the user making the request will need to have both the admin and the customer role, both of them. It's the same if you place multiple roles here. This is not working like an OR. This is working like an AND. So if you place multiple roles here, the user making the request must have all of them. Well, and then you can override other things like the rate limiting and the override of the headers, etc. Okay. So now I have established this basic thing. There are some advanced options for rewriting in a custom way, and there are also some advanced settings that can be used, like the balance algorithm, in case you have you want to use API Umbrella as a load balancer, which is also an option. And well, you can configure a lot of things. I'm saving this, and now I need to publish the changes in order to make them live. So I have published the changes. What I'm going to do now initially is to start making requests using an API key. So what I'm going to do is, for example, using this local user. This is the API key from this local user, and I'm going to say that this user is a customer. Okay, well, first of all, I'm going to make the request just like this. So if you see, I'm going to make this request. This is the path. This is the URL from Umbrella. This is the path I have configured. And when you are using, this is the FIWARE service tenant I'm trying to access. And when you are using an API key, the header to use is this one. So if I make this request now, you will see that I'm not authorized to make the request. So if I configure the customer role, you will see that now this user is authorized to access to the street lights information in my context blocker, as you can see. Okay, so this is the basic security that we have. We have created an access policy saying that users with customer role are able to access to my context blocker tenant with street light information. But what we have done until this point is only configuring this with an API key, which is not enough for more of the scenarios. The API key stuff is good for debugging, or it might be good in those scenarios where you have some kind of machine-to-machine communication, whether you have not user involved and these kind of things. But for an scenario with final users, you are typically want to have something a little bit more secure, which is the case now. You will want to have your user, you will have your identity manager, you will have your OAuth stuff, the one which you are using in order to secure all the FIWARE stuff. So this is what we are going to do now. If we come here, you can see that I have an identity manager and a Keyrock instance where I have registered an application called context blocker with a URL for the context blocker. So if I'm accessing here, what I need to do is picking the client ID of this application. I need to go back to the API backend configuration. And here in the global request setting, we have something which is called allow external authorization. With the allow external authorization, what we are saying is this, for this API backend, we are going to support access tokens issued by a Keyrock or a Keycloak instance. In this case, we have a Keyrock, and I have to provide here the client ID, the client application that we are going to use in order to get the roles from. So I place here my client ID, and the only thing I need to do is to save this and to publish the changes. Okay, so now, if we come here, we can see that I have a role defined which is called customer, the same name I had used previously in the API key. So the first thing I'm going to do is trying to make a request is to the identity manager in order to get an access token. I'm going to use this user. So I send this request in order to get an access token. And I'm going to try to get the lights. When you are using an access token, instead of the X API key, you should use the standard authorization bidder header. And making this request, you will see that I'm not authorized to make this request. So going back to the identity manager, I can come to the authorized user section, look for my owner user, and give him the customer role. So once I have done this, I can get a new access token. And if I make this request, now I'm able to access to the service. Okay, so what we have basically done is we have set up our API backend, we have configured the redirection to our context blocker, and we have created an access policy saying that in order to access to the Lightning FIWARE service, it is needed to have the customer role. This stuff is integrated with a specific application defined in Keyrock, so you are able to create roles in Keyrock, assign those roles to your users in Keyrock, and those users which the specific roles are able to make the request. Other users are not authorized to make this specific request. Okay. And now I want to show you a little bit more advanced. This is a real API umbrella working. This is not local anymore. This is an instance that we are using in production. And what I want to show you is that the website backend functionality, where basically, well, you can access here website backends, and here you can define all the redirections. For example, we have here an instance of a FIWARE generic enabler, which is called WireCloud, and you can see that using API Umbrella as a reverse proxy is quite easy. You only need to provide which is the front-end host that is going to be by users in order to access here, and then which is the backend protocol, in this case HTTP, where is the website actually working, being served, which is in this internal URL, in this internal backend port. So every time you make a request to this using every time you make a request to this, you are going to be redirected to this specific server. Typical configuration for a reverse proxy. And the final thing I want to show you is the analytics stuff. The analytics stuff is placed here. You have the option to go to the API drill down. Here in the API drill down, you have this view where you can establish the time period you want to see the different analytics, and then you can play with the different filters. You can add ands or ors to the query that is computed, and then you can access and you can filter for all this kind of stuff. You can see that there is a lot of things, the HTTP method, the specific host, the IP, the user agent, the by user, by response, etc. You can filter whatever you want. But the basic functionality for the API drill down is showing all the different APIs you have here, and then you can do this drill down. See the number of calls for the different paths that you have in the system. Apart from the API drill down, you can also view the different analytics by user. For example, selecting a specific user, you can see all the requests the user has made with its timestamp, the HTTP method, and all the information, and also the location. And here you have the chart with all the information, etc. And finally, you can also have some logging by location. So you can see here in the map that, well, most of our requests are coming from Spain, but we also have requests from China. We also have requests from Sweden. This is quite useful in order to track attacks and these kind of things. For example, if we go to China, probably we are going to have weird stuff. Well, we have one from Weihai, and then we don't know others. But in general, the point is that you can track the location from the different requests. Okay, so this is all from the basic points. So now I'm going to give the presentation to Dennis so he can continue with the advanced functionalities from API Umbrella.
All right. Thanks, Francisco. All right. So what I want to show now is the advanced use case where you want to have an attribute-based access control on your APIs. And this whole use case is implemented within a trusted data space. And we implemented this as a part of a project called I4Trust. So just one slide now to data spaces and I4Trust. So what is this data space? Basically, data space is an ecosystem built around some technical building blocks which allow you to have an effective and trusted sharing of data among different participants. And I4Trust now is a project supposed to boost the development of services within such trusted data spaces and providing the different technology building blocks for building up such data spaces. And these building blocks just shown here what some data space could consist of, having different categories of these blocks for data interoperability, sovereignty and trust, and for the data value creation. What we are focusing now on here, since we are in the webinar about API Umbrella, we are on this trusted exchange and the access and usage control and policies part. And there we are using now building blocks from FIWARE, for instance, now API Umbrella, of course, or also then the context broker technology providing these services in the backend, and technologies from the iSHARE framework, which is also part of the I4Trust project. So I also want to show quickly what's iSHARE. And this iSHARE framework actually aims at improving such data sharing conditions and providing a framework which focuses on the topics of identification, authentication, and authorization. And looking at such data space here again, this usually will consist of some provider, either data provider or service provider, and some consumer, and then several other participants, like of course identity providers, as soon as you have human users involved, maybe even some marketplace instance where services can be offered and acquired, and also authorization providers or authorization registries storing the access policies when accessing certain services. And on the top of all of this, you will require some trust provider, which creates a trust among all the different participants. And in this iSHARE framework, identities are based upon this building block called EIDAS from the European Union. And now, but two important concepts now from iSHARE, which are important for this use case now, is on the one hand is the JSON web tokens used in any interactions when you need a non-repudiation between the different parties. For instance, when you have any type of authentication processes, maybe based on OAuth or OpenID Connect, and iSHARE clearly defines how such JWTs should be signed according to the JWS standard, and supposed to have a specific payload. So here's an example how such a JSON web token could look like, especially where you have your EORI IDs of your organization. When you sign your JSON web tokens using your private key, which you get issued within this trusted data space. And then on the other hand, you have these authorization registries where you can store the access policies, and just showing here how such an access policy in this iSHARE framework now looks like. Most important thing is every policy is issued by some organization and has a target subject to whom this policy is issued to by this organization. And then you can have an array here of different policies, which in the end allow you now to define on an attribute-based level on what some user and organization can do when accessing your service. And basically it's 4 different parameters. On the one hand, it's a type you can specify which someone is allowed to access, a specific identifier, an ID of the object to be accessed, then certain attributes of your objects, and finally certain actions which, for instance, could map to certain HTTP methods like a GET or POST operation. So that's the basic ingredients now, and then I'm coming now to the specific use case example we developed at i4Trust. So what we wanted to show here now is how to delegate the access rights for such a data service now within the trusted data space. And it's important here is that this delegation of these access rights allows to delegate them from an organizational level back down to a user level, so that in the end some human user can access the service. And by doing this, the actual service provider does not need to have any knowledge in the end about the final user accessing the service. Shortly about the specific use case, we have several parties involved here, also pictured here on the right side. On the one hand, there is some packet delivery company, some packet delivery company delivering packets, and they are exposing a service where you can access the information about your delivery orders, like the address where it should be delivered or the planned time or date of arrival. And even they also allow to change certain attributes. So for instance, to change the planned time of arrival of your delivery order. So this packet delivery company here is now would offer the service now on some marketplace, which is supposed to where some such service providers can offer their services. And then there's different retailers, e-commerce shops, like these No Cheaper and Happy Pets, how we named them here, which acquire access now on this via the marketplace to this service, and then can delegate the access rights for accessing such service to their customers. And there might be even different levels of these offerings. For instance, a standard one where you really can only get read access to your delivery orders at this packet delivery system, or even a premium service which allows you then even to change something like a planned time of arrival or your delivery address. And in the sense of these policies, these different levels of these offerings would be represented by different access policies, of course, but I'm coming to that. Okay, the basic architecture we have here in this data space is it's like similar picture as before, but with some more components, especially now on the side of the packet delivery company. For instance, you have, of course, you have this context broker, which is actually the instance providing the service. So delivery orders in our use case example here are now just entities stored at the context broker of a type delivery order with certain attributes. And in front, this API umbrella, which is protecting the access to this context broker and allowing to access the service externally. And then there are these authorization registries, on the one hand, at the packet delivery company, but also in the environments of the different eShop organizations like Happy Pets here. So allowing, for instance, here to store policies issued by packet delivery company to certain organizations, and also an authorization registry at the Happy Pets organization, allowing to delegate or to issue policies from Happy Pets to certain customers that are registered at their identity providers, where these customers have registered in order to shop at their system. Now, what this packet delivery company needs to do now first is, of course, creating an offering. It's this marketplace, or even different offerings like the standard and the premium one. Configuring these offerings and make them available for other organizations to purchase access via this marketplace. And they need to configure their API umbrella. Francisco showed it in very detail how you can configure an API backend now. Mainly the most important part is this authorization mode drop-down, where you, instead of the role-based access, you have a context broker attribute-based authorization mode now, which you need to select. Of course, configure the context broker backend, but in the end, basically, that's all one needs to do. Now, let's say this Happy Pets organization, there's some employee now, they want to acquire access to this offering of the packet delivery company. So you will go to this marketplace and log in there, and any interaction among these different participants, you see there's also this trust authority. There are always checks against the trust authority, whether someone claiming he's from some organization can always be checked against the trust authority, whether actually this organization is a trusted participant of this whole data space. So among all interactions, there are requests sent against this trust authority here. And now when this Happy Pets employee acquires access now to this premium offering, which would allow you to read and change delivery orders, what the marketplace will do now is creating an access policy now at the registry of packet delivery company, which is offering the service, which would look like this now. So you have a policy issued by packet delivery company, of course, to this Happy Pets organization. And for these different parameters, access would be now allowed to entities of the type of delivery order on any entity IDs. And on this example now, only certain attributes, let's say, for instance, to do to access the planned time of arrival and the planned day of arrival, this PTA and PDA, and to perform actions of type patch and get. Especially changing now delivery orders would mean to allow this patch access. now this access is granted for the organization of Happy Pets, but in the end, we want that human customers of this Happy Pets organization wants to access the service. So after Happy Pets acquired access to the service, now needs also to delegate this access rights to their customers. So this means also storing policies at their own authorization registry, which basically will look similar, also allowing these, for instance, these patch requests on these certain attributes on these delivery orders. But now these policies are issued by Happy Pets to these certain users. Of course, this is most probably some process to be done when some customer signs up at your shop system, will automatically get issued such policies then in the registry. Now, let's come to the actual use case. So now this customer of Happy Pets, let's assume he already shopped something, he ordered something at this Happy Pet store, and there was also already a delivery order created now at the packet delivery company, so there's an entity at the context broker, and now this customer wants to change the planned time, the arrival of his packet delivery order, for instance, to moving it somewhere to the late afternoon. So what he will do now is there's some portal application also provided by this packet delivery company, so he opens up this web page and now can log in using the IDP of the Happy Pets organization based on the OpenID Connect protocol. It's similar as you would like, for instance, have an option here now to log in using your Google or Facebook account or something. Now you can choose the IDP of Happy Pets for logging in. Of course, there's also again a verification against the trust authority, whether this portal application is trusted participant here of this data space. And now when performing this login process and when the customer entered his credentials, what this customer obtains or will be stored now in the session of this portal application is such a signed JSON web token now issued by the IDP of Happy Pets, containing the access policy stored at the registry of Happy Pets about this specific customer user. This is how it looks like. And as I've shown on the slide before, so policy issued by Happy Pets to this user doing these patch requests on delivery orders and also on attributes like PTA and PDA, and also having these JSON Web Token attributes here about the issuer and the subject. And of course, this whole JSON Web Token is signed by the Happy Pets organization. So the Happy Pets organization is owning some private key issued just for them, so that they can sign these JSON Web Tokens and prove that's a JSON Web Token coming from the Happy Pets organization. Now, finally, this customer will invoke the service using this portal and now wants to change this planned time of arrival of this delivery order. So what this portal application will issue now is sending a request to API umbrella now, an NGS ILD request actually, doing a patch now on a certain entity, certain type, and on a certain attribute, and adding the new value for the PTA. And what API umbrella will do now, first, of course, is to validate and verify this signed JSON Web Token using the root CA and the signature of this web token. And when this could be verified, now API umbrella needs to evaluate from the incoming NGS ILD request what is the actually required policy to perform this request. So it needs to translate the parameters of this NGS ILD request into a policy in this iSHARE format. So identifying, okay, it's going to access an entity with this ID of type delivery order, it's going to access this attribute PTA, and it's going to do a patch request. And this is reflected then in this policy. And what API umbrella can do now, since this user sent along with this NGS ILD request, this JSON Web Token in the authorization header, now to compare the required policy to the policy actually issued by Happy Pets to the user, and if these match, and in this case it's the case, API umbrella can continue, but it won't allow now the access, because what API umbrella knows now is that this organization Happy Pets allowed access to this certain customer to do this. But API umbrella does not know whether Happy Pets itself has access to the service from packet delivery companies. So in the next step, it needs not to verify also at the authorization registry of packet delivery company if there is a similar policy, but now issued by the packet delivery company to Happy Pets. So you have now a delegation of these access rights, because on the one hand, you have this user level policy issued by the Happy Pets organization to their customers, stored at the registry of Happy Pets, and you have this policy now stored at the packet delivery company, issued by the service provider to this organization that acquired access to it. And only if also there's such policy now allowing this required, allowing this NGS ILD request, which maps to this required policy, then finally the access is granted and the request is forwarded and the attribute gets changed. That's basically what I wanted to show now. And I think there's a bit time for questions, I think.